The next keynote session is by Ivan Panchenko from Postgres Professional. Ivan joined us, but yes, just a second. Hi. Good day. So Shalom. It's a new feature in PostgreSQL 14. Welcome.
Okay. So probably I need to share my screen now. Just a moment. Okay. Can you see it?
Yes.
Okay. So PG14 is the latest version, just very fresh one. But of course, all the new things that comes with this version are already known from Spring after the feature freeze. And of course, there are lots of articles describing these new features. And probably some of you have already read some of these articles, and maybe some of you have read some new documentation about these features. So, of course, for me, it is not interesting and even impossible just to list all of these features, just to enumerate them. You can read this in the release notes. So I will focus on some features which, for me, look most interesting, or I tried some of them, or I discussed them with my colleagues, so I have something to say about these features, or maybe I just want to know them because they are extremely interesting. And my rating differs from the official rating in release notes. So for me, the most important, most remarkable features are other than from the viewpoint of release notes. Okay, so let's start. So first and the most interesting feature for me is the improving of the connection scalability. Postgres Pro has lots of customers which have large servers with large amounts of CPUs. And so scalability for us is a very important issue, and we also work on this. We have some other patches in Postgres Pro, especially we made patches for IBM Power CPUs. Some of them are published. But now we see that there is an amazing work by Andres Freund, who made several patches described in the articles under the links, just to improve the scalability with connections. Result, according to the test of Andres, is really very remarkable. So after the saturation, you see the performance doesn't decrease, and that continues on some fixed level, which is natural. So when a number of connections, active connections, reach the number of CPUs, there is no growth more, but also there is no decrease. It's good, it's very good. And of course, it's for large customers, for customers which have servers with large number of CPU cores, it is very important. But I want to just note that this great number of TPS is for read-only, very simple queries, which are done completely in memory. Why so? Just to show the effect. This effect is, of course, most noticeable when the transactions are very short, very simple, and there is no disk interaction. Okay. Next interesting feature is called bottom-up deletion. It means that there is some optimization in B3 algorithms, which can reduce bloating of the index significantly. So, no, sorry, update. Bloating during the updates can be decreased significantly. So the algorithm is very easy, just before splitting B3 page. Now Postgres thinks maybe I shouldn't split it and find some place on this page But the place can be found if there are dead tuples on this page, and they can be removed. So some part of vacuum work is done just during the update. And in this case, you see that during some popular workloads, which update a record many times without changing the index key, so the new version comes to the same page of the index. This page is not bloated. It's very interesting and really removes bloat in many practical cases. So it's a great feature. Okay, next is asynchronous append. So it is it's not popular, but for me it is interesting because we have several cases of sharding which is made on the base of partitioning and foreign data wrappers. This feature means that the foreign partitions, so the partitions which are in foreign tables, can be scanned asynchronously. It is a very good feature, but as every distributed query, it also needs distributed planning to be efficient. So it is just one step to full-scale sharding on the base of FDW. But this is a great and important step. Next, covering indexes are indexes which are enough for making some queries. So Postgres can make index-only scan without looking into the heap. So if the query uses some fields that are not present in index, not indexed, then several years ago, Anastasia Lubennikova made a patch to introduce the include keyword to the create index command. You can include into indexes some fields which are not parts of the index key, but some additional information to increase the number of possible queries which can be done with index-only scan. So having these additional fields inside an index just save you from making full scan, from making index scan with heap lookups, just when you can use only index because it contains all necessary fields. It's some kind of index organized table, but not complete, of course, table. So such include keyword now works not only for B-tree, but also for SP gist index, and this is spatial index, so you can make index-only scans with spatial data, with spatial queries. Okay. Next set of changes are connected with vacuum. There are several changes which make vacuum more efficient. So you see that there is a change of default parameter value. On my slides, green is new. So the reduction of cost of parameters which connected with vacuum means that usually disks get quicker in comparison with memory. So they are not disks now at all, just some storage. So default values change to reproduce their performance more adequately. So next, very important thing that create index or reindex concurrently do not block vacuum. So it allows you to work with indexes without fear that vacuum will be stopped and table bloat will grow. Another thing is that if vacuum finds that during heap scan, there is no significant amount of dead tuples, then it will not vacuum the indexes, because it gives just no advantages. So vacuum runs faster. Another thing to make vacuum faster is option to make it without processing toast. Maybe sometimes you don't want to vacuum toast record, so you can set it to off. And the last feature about vacuum which I want to note is that auto vacuum processes exit now when postmaster aborts. Before that, you can kill the postmaster and then observe how auto vacuums continue working. Now they are stopped automatically. And we come to replication. There are some parameters changing which is fatal to standby. So standby will stop if you change some of the parameters. It is so because if these parameters change, then standby can't replay the walls. But now in this case, just the replication is stopped and standby continues to work. So it continues to execute queries. It's not so fatal. You can change these parameters on both servers, and then the replication will continue. Okay. Another thing to make replication more flexible is to allow changing the restore command on server reload without complete restart. PG rewind can use standby on the source, so it's not a principal change, but just PG rewind. Before that, required it made some temporary objects, and so it couldn't work on the read-only database. Logical replication of large transactions. Before this change, if you replicate a table logically and you perform a long transaction, then all the data which should be replicated, it was stored on the source server just until the transaction ends. If transaction is larger with gigabytes of data, it is very it is very greedy for space, and of course it is not effective because the replication starts only after committing the transaction, and transmitting the data also takes time, and applying takes time, and the transaction is longer if it's synchronous. So it is not optimal, and that's why now the logical replication can stream the data. It means that the data become transferred to standby just during the transaction without waiting for it to be committed. Another change is to allow so-called binary format for logical replication, which is just faster. Next one, next set of changes is connected with the system views. So now Postgres has a query ID in its core. Before that, we had query ID only in PG start statement extension. Now we have it in core. And if we turn it on, then we can, for example, join PG start activity with PG start statement and maybe some other data. Okay, so this query ID also, it is seen in explain, and you can print it to the logs if you use %q in logline prefix. Another system view, a new system view, is additional to PG start statements, and it shows how many times the PG start statement tables was reset and when it was reset last time. So looking to this table helps you to tune your monitoring, to tune your usage of PG stat statements. There are several new system views. One of the most interesting just for me is PG stat wall, which is useful for monitoring wall traffic. So you can see how many records were and so on. And now you can see also IO timing if you turn it on. So here you see the complete time which was spent for writing, for syncing, additional to a number of times writes or syncs were done, additional to number of bytes which was written, number of full page images which was written, and a number of records. Also, you have you see here reset time, and you can reset it with pgstat reset function. Okay. Result cache is a new executor node, so it's a new operation which you can see in the query plans. It allows you to cache inner loop results in nested loops. So if you join some tables with, and Postgres use nested loop for that, then you can see that sometimes it will cache the results of the join of internal loop. So nested loop can be seriously faster if just because it reduces number of scans. Another optimization is concurrent reindexing to other table space. So now you can reindex a table concurrently to other table space. So it is log-free in comparison with old alternatives. Before that, you need to alter table or alter index to move to other table space, which of course requires a lock of the table for a long time. Or another alternative is an extension, PG squeeze from Cybertech, which allows also to move table indexes without locking. A new, but a very arguable thing is pipeline mode in libpq. So it allows to execute several queries in a pipeline asynchronously, then send them without waiting for result of previous query. So it's a new mode for libpq, but to make it useful, we need to support it in some high-level clients, which are usually used with Postgres, but maybe on low, on the high latency networks, it will really improve the performance. Of course, it works good if you have multiple short statements and the logic of your application allows you to issue them asynchronously. Okay, foreign data wrappers. I have already told something about foreign data wrappers today, but there are more things. First, these are new options. Keep connections, which is on default on now, but you can turn it off. It means that Postgres will disconnect immediately after executing a query. So before that, after executing a query with foreign table, it continued to keep the connection, waiting for probably other query with the same table, but it is not always good just to keep some connections. So now you can tell Postgres to disconnect immediately. Another new option is batch size. It makes Postgres send inserts to foreign table in batches. By default, it sends it one by one, but you can increase the number and send the inserts just, for example, in 100 or 1000 inserts at a time. So all this allows to use with foreign servers in a more optimal way. Also, there are some new features, such as automatic reconnection to remote. So if you keep the connection, but there is no active transaction now, and a remote server is restarted, then the connection will be restored automatically. Also, you can now truncate foreign tables, which is of course useful, especially when you are using sharding with different servers and, for example, time partitioning. Sometimes you need just to clear some pages of some tables, okay, some partitions. Another thing which is connected with scaling, which makes Postgres more scalable now, it means better scaling with a number of parallel processes. So when you execute queries in parallel, a new feature is to preallocate memory. And you see the linear growth continues just to a very large number of processes. So turning this parameter on and setting it to some value which you choose experimentally can increase the performance of your parallel queries. Okay, statistics. Now you can you can create statistics on some functions or expressions. It is good. Also, there are some optimizations for using extended statistics in expressions containing ORs, and optimization which makes empty table has 0 records. So before that, it was not 0. Another thing that can be done concurrently now is detaching partition, which is done without stopping queries. All transactions continue to see the partition, but new transactions don't see it. Also, you may create index concurrently on different tables in parallel. Before that, you can run it only once per database in parallel. Now it's much easier. So other features, just a collection of things which are helpful, and I noticed them, or my colleagues have tried them. So toast compression. There is a LZ4 algorithm, which is very interesting because it runs faster than a normal algorithm, though it is not so effective. But you know that toast sometime very often becomes a bottleneck. If you have large records, large JSONs, for example, then compressing and decompressing it many times just require a lot of work. In such cases, LZ4 algorithm can help. Unfortunately, I have no benchmark now, but it will be soon presented on some of my or Oleg's talk. Truncating a remote table. Oh, probably I already have spoken about it. Okay. Idle session timeout is a new parameter which allows you to kill idle sessions. So there is optimization which allows to clean up shared buffers more effectively after truncating, dropping table, and so on. This is not first optimization of this kind in Postgres. Caching now function. Also in system views, some new attributes, such as top-level attributes in PGStat to distinguish between top-level queries or queries that are called inside other, for example, inside functions and procedures. New attributes wait start in pglogs. So it's just a timestamp that shows when the waiting has begun. Some compiler level optimization. So now error handling is marked with cold pragma. So a compiler tries to make the code in such a way that it knows that these branches of execution are not probable. Incremental sorting is used inside window functions. So there is some optimization of gist index creation. By the way, there will be a talk about this at PGConf Russia in the end of October. Reindexing partition tables. So B3 gist now is parallel safe and can be used in parallel queries. Very good for spatial queries. Okay, значит, next is parallel sequence scan, which now can read, okay, so it can work with sets of blocks. It means that it requires less interaction between processes because the blocks to scan are distributed between the workers, not one by one, but by some large sets. And next thing is syntax. It's a subscripting syntax. It is a patch which has a very long history. It started, I think, 6 years ago, but now it is committed. So for JSON data, we can update just with like an array with indexes at the left of assignment operator. New roles, which are simplifying work of database developers and administration. So now you have a role PG database owner, which is automatically mapped to the owner of the database. If it changes, still this role will come to the new owner automatically. Also, there is a read-only role and a role which allows to write to all data. Before that, we need to write some scripts just to grant select on all tables. But now there is just a role, and we can grant this role to user, and he will automatically get access on all tables in read or write mode. Also, there is a new feature to cancel long queries on user disconnect. There is some interval in server parameters, and if it is small enough, the connection will be checked during running the query, and if connection disappears, then the query will be canceled automatically. Okay, so I'm coming to the end. At the end of my talk, I just want to tell about PGConf RU, and this conference is offline now, but also it has a possibility to see it online. So it's a hybrid format. It will be at the end of October. And there will be several talks on new features of PostgreSQL and many practical talks from Postgres DBAs. So I can invite you, just come online. This conference is in Russian, but there will be simultaneous translation into English for those who do not know Russian language. Okay, so thank you. Now questions, please.
Thank you, Ivan. Yes, there is one question. If you can please read it in the QA. The question by Eli Marmor. Yes, do you see it?
Just a moment. Not now. Yes, I see it. temporality. Okay, a nice idea. Oh, it's also a very long story to make temporal tables in Postgres as a built-in feature. There were some discussions, some speculations about that, but I don't know if anybody is working to include it into Postgres. Maybe because there are several ways to implement this, and for opinion of many people, this is a feature of higher level than database itself. Though some people think that everything depends on standards, and if temporal features will come to SQL standards, then Postgres will have to implement them. So maybe you work with a standard commission, just it will then we will have to implement this inside Postgres.
Okay, understood. Thank you very much. Yes, for the so detailed explanation, and hope to meet you once again. Yeah, I think soon. Yes, maybe in 1 week. Thanks. So now we will have a short break. Our next topic is by Francesco Tiziot. Yes, we schedule it to 40 minutes or 20 minutes before 2 or 40 minutes past 1. So let's get back by this time. Okay, thank you very much. So enjoy your break.